Today's talk really is a talk where I hope to compare the existing USP 665 chapter, the BioPharmaceutical BPOG risk assessment approach, and another approach that is, I think, a little bit more holistic in terms of leachable risk management. So I want to talk about leachable risk management as a subject. And therefore, the contents of this presentation will start off with a couple of slides around what do I mean by risk management, and then I'm going to go on and describe a little bit about the BioPharmaceutical approach and what I see as a few gaps in that. And I'll follow up with the USP approach and do a similar situation here with a few gaps. And after that, present this alternative, which I hope fills some of those gaps. So, what do we mean by quality risk management? Well, it's quite helpful that ICHQ9 has existed for quite a long while. Not quite sure when the original submission came out, probably mid-2000s, something like that. We're now on revision number 1 of that quality risk management, and there's a very well structured approach here to risk management. And the first thing I want to say is that I'm certainly not into reinventing the wheel in any way, shape, or form here. So I think we should look very carefully as to whether an approach like this is an approach that can be adapted for leachable risks. So one of the two bullet points that are on the screen right now are right up front in terms of that ICHQ9 document, that an evaluation of risk should be about scientific knowledge and ultimately linked to the protection of the patient. So that seems to me fully aligned with the leachable risk. And secondly, that the amount of effort, the formality, and the documentation of that risk should be aligned to the risk level. So again, I see no issue with doing that. Some of the terms within this document are also very, very helpful. And I chose to sort of start with this because I think getting these terms clear and understood are fundamental to any process that we're using here. So when we talk about risk assessment, it's quite tempting to use it in many, many different ways. We see, say, safety risk assessment using a particular standard. All of these are using that word risk assessment. But what do we really mean by risk assessment? I think the fundamental parts that are listed here are very, very relevant. What might go wrong? How likely is it that it's going to go wrong? And what are the consequences or the severity of when it goes wrong? And I think some of the standards that I'm going to talk about in a minute don't have these elements front and center. So I think that's an interesting piece. Another term here, hazard identification, used to be called risk identification. Actually, I quite prefer the term risk identification. But hazard identification, a useful first step and fundamental to this. Risk analysis, this is where we go on and we actually score the risk in a qualitative or a quantitative sense. So again, a fundamental step. And that step includes a consideration of what we don't know as well as what we do know about something. And there's no reason why we can't incorporate that into our scoring. And finally, when we have a score, what are we going to compare that against? Doing an evaluation in a thoughtful, prospective manner around the risks that we now have scored. What do we then think about them? So after that, once we've done the actual analysis piece, what are we going to do next? We're going to obviously want to control the risk. This is where we have to be really clear-minded about, are we going to accept the risk or are we going to try and reduce the risk? Accepting the risk can mean a couple of different things, actually. It can mean the risk is pretty low, so it's fine, we don't need to do much more. Or we've done this very detailed analysis and we really realise that the risk has to be accepted at the level it is. There's nothing more we can actually do. So we've got to put some sort of control mechanism around it, some sort of special mitigation to keep very close control of it. So risk acceptance is a interesting thing. And as you can see, the risk reduction is where we actually do something to reduce the risk. So I like to come on first of all to the BioPharmaceutical approach. This, as I say, has been around a very long while now, well, relatively long while, 2018, and it, as others have presented today, it's very much centred around a selection of leachable risk factors, and one of those is the distance along the production biopharmaceutical production line, and there are these other factors that are included here, and we'll go into a little bit more detail in that in a second. So the document itself I've read several times, and it, in its totality, it has lots and lots of useful information in it. It starts right up front with saying, this is the sort of information we should collect, and I haven't really got an issue with any of that information. That information is all exactly the sort of information I expect people want to collect in terms of looking at risk. But what I see as a sort of first gap, if I want to identify, that there is no explicit instruction how that collection of things that we have here are then fed into the risk assessment process. The risk assessment process almost doesn't mention it again, and that's a little strange. The other thing, the last bullet here, is about pre-existing extractable information. I think everybody would recognise that pre-existing extractable information is really useful, and it's something that we should incorporate into our risk assessment. We shouldn't just ignore it and do some more extractable analysis. It really should alter our outcomes. So once again, it's not clearly directing what to do with that pre-existing extractable information. And the last aspect that I want to sort of focus on before we go into the actual risk assessment model itself is that the BioPharmaceutical document says this is really just about the probability of leachables, and therefore it's explicitly excluding that severity of hazard. So half the risk, a big component of the risk apparently is out of scope of the BioPharmaceutical approach, which seems very strange. There is no mechanism, and I've looked several times, within the scoring that recognises what we know or we don't know about the toxic approaches of the materials and the substances within those materials. So I'm sure you're all aware of the model itself. It has these features around the factors that you apply, the weighting that you apply to it, and then a score that is then derived from it. And the score that is then directing you to high, low, or medium. I'm not sure what the obsession is with high, low, and medium. For me, everything has to be... Why high, low, medium? That just seems an arbitrary choice to me. But anyway, all of these, this and USP 665 has high, low, medium. So anyway, we have high, low, medium. And then it directs you to say, this is what you need to do if it's low, this is what you need to do if it's medium, and this is what you need to do if it's high. And for me, that is not aligned with leachable risk management. You shouldn't expect a particular set of tests to always be applicable to a low risk, a high risk, or one in between. So I'll point that out, and it's a point I'll come back to with the USP testing too. So other aspects here are that if we do go down that low route, we end up with bumping into the idea that if we have a low risk, we can discharge that risk by performing these particular tests. If you look at the difference between the medium level and the high level, it appears to say if you've got a safety evaluation, that's what you do with the high level, but you don't have to do that with the medium level. So it's a little strange in that regard. So that there doesn't seem to be a great deal of differentiation in terms of what you do once you've actually derived those risk levels. And pre-treatment. We've talked a little bit today about X-ray. There is no explicit acknowledgement of how pre-treatment affects the scoring under the BioPharmaceutical system here. It says it's something you should consider, but it's not built into the scoring. So purge points, that type of thing, not affecting the scoring. So if you also apply this and do the scoring, the most common outcome is a medium score, and on that basis there isn't a great deal of differentiation within this particular risk model. So that's what I have to say about the BioPharmaceutical. I'm going to move on to USP. First thing I want to say about the USP 665 is its scope is different from the BioPharmaceutical scope. It's designed with a wider remit. It is used for all types of manufacturing components. So I guess that perhaps makes a difference. What it says is in scope is liquid and semi-liquid processing streams, but it excludes non-plastic componentry, such as diaphragms, gaskets, and O-rings. And I don't quite understand why. There doesn't seem to be a particular reason for that. There's this separate term of plastic auxiliary components, which are small, and perhaps that I can understand their exclusion on the basis of their exposure. But there are certain things excluded. And then there is this cross-reference to 1665, and the interplay between those are absolutely important. The last thing I want to say at this point is, and I heard somebody say it earlier today, is that 665 is a sub-1000 chapter. But my understanding is, and please somebody shout out and correct me if I'm wrong, it is not compendial applicable. It's only for information at this stage. The general chapter is below 1000, but it only becomes a standard when it is referenced in another monograph, and as such, this at this point is not that. So that's just an interesting thing. Onto the standard process itself. A great deal of the standard process in 665 is around, is it in scope or is it out of scope? There's a very clear decision tree to take you through that. But there's also this piece around equivalency, and there's some steps here to mark out the equivalency, quite a lot of steps. And I guess it seems to me that it would be actually quite hard to meet equivalency on the basis of what's here. But I guess I don't want to step too far into the detail of that, especially since I don't have a great deal of time. So into some of the detail here. There's a list that's in 665 that talks about what the process is, and I guess I have absolutely no issues with the format of this, in the sense that a risk assessment should be these things. It should establish the appropriate contributors of risk. It should provide a means of quantifying that risk. And the total risk is a combination of its individual parts. The last part here, though, seems a little at odds with what I believe a risk assessment to be. Linking a risk to appropriate characterization strategies. This is the same flaw that I see in the BioPharmaceutical approach. A risk assessment for me is just establishing that you have a risk or not a risk. I don't see how you would then automatically be able to suggest what an appropriate strategy to characterize and reduce that risk is. So that's just a personal view on that. When we start to get into the detail of how to do the risk assessment, because I guess fundamentally all 665 suggests in one sense is that a risk assessment should be done, but it does so in a way that unfortunately binds you to the guidance chapter 1665. You cannot easily do the risk assessment and remain compliant, whatever that might mean, without going through 1665. That obvious example of, you have to have 3 levels. Okay, why not 2 or 5 or 7? So there's a binding there between the two processes. So if you then dip into 1665, this is where some of the additional issues for me arise. So 665 directs you to 3 levels, low, medium, high. What it also suggests is this solvent system to go alongside the assessment. And this is an area that I had 2 issues with, hence 2 boxes. One is the solution C1, which is a 50% ethanolic solution, quite an aggressive solution. That's reserved for every single risk level. And the high level introduces 2 additional solutions. But those 2 additional solutions are most likely to produce lower amounts than that C1 solution. So what is it about those 2 additional solutions that mean you should introduce them at the high level only? I don't quite understand that, other than the fact that you get more information. But the information you get, you're probably getting from C1 anyway, so I'm not sure about that one. The other thing that I'll kind of just rush very quickly past, because it's been commented on a couple of times today already, the introduction of non-volatile residue and UV absorbance, it doesn't really give you any advice as to how to implement a problem with that. In fact, it's what is a large value is left entirely to the individual company to decide. So we then look at the moderate and the high level testing. This is the same issue as I was mentioning before. Those 2 additional solvents, what are they actually adding to the risk assessment? I struggle to see in practice the difference between the moderate level and the high risk level in terms of the information you will actually get. The last thing I'd want to say, kind of around the 665, is the scoring that 1665 actually draws into the risk assessment. There are some issues with that scoring from my point of view. The first one I'll point out is the factor around chemical composition of the component. Most people, or a lot of people, say most, a lot of people struggle to look at this in an objective way because they don't have the information. So they automatically are forced to go to the high risk level to be conservative if they don't have that information. So you're already sort of blocking out one of your variables, as it were. If you think about the other dimensions here, you have a compositional dimension here. But in the text of 1665, it suggests that if you have a 2% protein and a 0.2% surfactant level, that would be classified as high risk. So a lot of systems are high risk according to that definition within biopharmaceutical systems. So you're now, two of your 5 variables have two of your 4 variables here have been sucked into high risk. And lastly, any irradiated system is considered high risk. So we basically said for biopharmaceutical systems, these are high risk systems. I don't know if that's the intention, but that's the reality of it. So when you feed that into the algorithm, you end up with 2 of the 4 dimensions likely to be scored at level 3. So you're left with temperature as pretty much the only variable in that initial assessment. And you're left to then mitigating factors to reduce that by 1 level perhaps. So in reality, if you apply all that to biopharmaceutical manufacturing, you end up with no low systems whatsoever. You only end up with the possibility of high and medium. So I will move on and talk about an alternative. Hopefully you now recognise the derivation of this alternative is based on ICH Q9. Basically rotated Q9's process and replace some of the items with the things that are slightly more applicable to leachable management. We have a risk identification step, a risk analysis step, a risk evaluation, which then goes on to risk control. So what are the key features? Well, I think one of the things that I'm very sort of passionate about is that we use all of the available information we have. One of the issues with the BioPharmaceutical and USP is that we seem to throw away that information or not consider certain information, whereas I think what we really need is a system that incorporates every single relevant piece of information that we have. So it very much should include the probability piece, but it should also have a consideration for the severity piece of what do we know about the type of substances that are in the materials that we concern ourselves with. And really what it then comes down to is being able to codify and score those things. So if we think about the first step, I haven't seen people talk very much about this, but I think it's a quite important step, is to write down what the risk is. Describe where it's happening in your process and describe what the cause and effect of that is. I find this a very useful first step. You know, this particular risk here is talking about the tubing of the filling assembly. It's not the tubing of the other tubing that's somewhere else in the process. You know, let's be very specific about what the risk is, and then we can go on to scoring. So if we talk about the scoring analysis, the key step here for me is a focus on the scoring, and what do we mean by that. Predefining this scoring and having it as relevant as it possibly can be is absolutely fundamental. And I was really interested in the UCB presentation just before mine had some of these features within it as well, making use of all of the information that you have and coming to a clear scoring position. So perhaps one of the things that wasn't discussed in the UCB piece here, though, was what to do when you don't have knowledge and understanding. And my suggestion here is that moderates the score. So if you know absolutely nothing at all, the default position is a score of 7 on this scale. If you know that you've got a problem, that upgrades it to a higher level. If you're pretty sure you haven't got a problem, you can downgrade it as long as you've got the information to justify it. And if you're very sure, then you can downgrade it completely. So this is the severity part, and there's some suggestions of how we define severity. And I would love for people to agree a position on what we mean by severity. I've linked it to the availability of biocompatibility, which some people may agree with or disagree with. And I've also linked it to, if we have extractable studies, what do they tell us? Extractable studies rather than leachable studies. It's an important point. So where this takes us is that the knowledge that we put in can be a theoretical knowledge or a practical not piece of data like an extractable study, and we should weight them accordingly. So in my scoring system here, the extractable study with a safety risk assessment is going to be the thing that affects that score much more than perhaps something theoretical. So when we swap over to the probability side of things, the same type of philosophy is present there. If we know nothing, we start at level 7, but if we're certain, because we've done the leachable testing or simulation testing, we can upgrade to 10 or 1, depending on what that leachable testing is telling us about leachable safety. And the same is situation with regard to the probability that we talked about is with regard to the severity here. If we just have probability factors, this is my suggestion on how we deal with those. I've outlined temperature range, time of contact, fluid composition, surface area to fluid ratio, a general piece about compatibility, and a recognition of a purge point, all of being important in establishing a score. And those combinations of flags, as is put here, can be put through an algorithm, and a score results depending on the number of reds, on amber, green, etc. So it's quite similar to the USP 1665 approach, I suppose, but I hope to think that these are a relevant set of parameters that everybody could actually use. So once we've done our risk analysis, we then move on and we make decisions around what we think about those scores. And what we think about those scores, to my mind, are best dealt with in not a 3 system, a low, a medium and a high, but rather a binary choice of whether it's low or high risk. And when we've identified it as low risk, we have the opportunity to do nothing, or we have the opportunity to do more if we choose to, but we decide on what to do on the basis of the risk that we believe is present, rather than an arbitrary choice of testing that has no bearing to the actual process we've risk assessed. I'm going to flick through these pretty quickly because I don't want to delay people any further. But when we get on to the testing then, we are talking about how we might do that risk reduction. And ultimately, we come back once we've done testing or process change or material change, all of those being options for risk reduction, to do a risk review, and that's the completion of the process. If we were to then instigate a change, that change would push us back around the process once again, starting again with risk analysis, reflecting the change that we made. So I want to leave you with these conclusions of mine, which really, you wouldn't expect me to suggest an approach that wasn't wonderful, would you? So I'm going to do that. But I wanted to highlight where I saw the deficiencies in those other two systems. So I will leave that up there for people to read at their leisure. Thank you.